So the next speaker today is a man who doesn't need any introduction. It's Patrik Fältström, Technical Director of NetNode. Patrik.
Thank you very much. So I'm going to talk a little bit about key management in two specific areas. They're not very much related to each other, but I was asked, well, why don't you just talk about both of them and we'll get done with it. So I'm going to talk about key management in DNS and key management in NTP. And the reason why I talk about it is, of course, that we at NetNode deal with both of these. Both are headaches in their own specific ways. So if we start with DNS. So some basics about DNSSEC for those who doesn't really know. How many people in here have a zone that they have signed? OK, that's good. How many of you are running a resolver that you think is validating DNSSEC signed responses? OK, that's good. How many in the room do run resolvers that you don't know whether they're validating or not? OK, good, excellent. So maybe this is good. Anyways, so the whole idea is, of course, like with any kind of information that we use digital signatures, normally we have asymmetric encryption. We have a private key that is kept secret, that is used for signing the information, and then we have a public key that is published in the DNS. So we use the DNS itself to distribute the public key, which is kind of clever, or complicated, or stupid, depending on how you look at it. But anyways, that's what we're doing. And the way things fit together is that we take the hash of the public key in a zone that is used in the zone, and we pass that hash to the parent zone. And the parent zone then signs the hash. And that's how we create the PKI. So you can validate the key. Let's see here. So you can validate the signature on a record by checking the public key for the key that have been signing the record itself, and then the records sign each other, including that in the parent zone, the parent zone's private key is signing the hash of the key in the child zone. So you get a hierarchy like this. And this then is used to do validation, just like any kind of PKI, by having some kind of trust anchor. There must be something ultimately that we trust. And one of the more and here in Sweden, just because we started signing things in DNS as the first TLD in the world, the first thing that we trusted were the public key for .se. But since a couple of years back, we can trust the key that is used for the root zone. So most validators that are validating things in DNS do trust the public portion of the key that is used to sign the root zone at the top. And the whole idea with doing this, of course, is that you should not look things up by using DNS. You need to have some kind of mechanism to get the key to be able to trust it, so you don't base your trust on something that someone managed to do some injection on some false information. So we can trust any key we want, but we have chosen to try to build the DNSSEC PKI on trusting the key for the key signing key for the root zone. And every validating resolver must have a trust anchor configured. This can be configured manually, or it can automatically be updated with the help of a standard called RFC 5011. What this RFC says is that, in a little bit simplistic ways, we use the existing key that we trust to validate that the next key is correct. So by trusting the existing key, we will trust the next key, which could be viewed as a little bit of cheating. But this also means that almost all validating resolvers today can do a replacement of the current trust anchor by trusting it to introduce the next one. The negative part of dealing with change of a trust anchor this way is, of course, if we do not trust the current key, which, for example, if it got sort of stolen or leaked or something, in that case, we cannot use that mechanism to introduce the next key, because if we don't trust the current one, how would we trust the next one that is introduced by the key that we don't trust? But anyways, RFC 5011 is something that is sort of good thing when we're going to do a planned change of the validating trust anchor. So one thing that we have never done for the root, but we did it for .se a couple of times, is that we have never changed the trust anchor for the root zone. Never, ever. We started assigning the root zone with one key, and that is what we have been using. It is actually, on the other hand, quite good to know that the trust anchor for the root zone for the DNS might change, because, well, there were some people in the room here, maybe they were lying, I don't know, that said you don't really know whether your resolver is actually doing validation or not. It's actually a pretty good thing to know. And from my personal perspective, one of the best ways of educating operational people that they have things that might break is to forcefully break things for them if they have not done things correctly. Okay? So I think that we should roll the key in a planned way by introducing a new key by trusting the existing one, which is using RFC 5011. Just by doing that, we will learn that the trust anchor might change. But note that this process that we are using is not something we can use for emergency roll. Don't mix these two things up. We are only doing this so we can roll the key if we change the crypto algorithm, if we change the key length, or if we are just sort of testing what to do. But anyways, by changing the trust anchor, everyone operating a resolver will, if nothing else, learn where the validating resolvers are. So let's try to do this, like today. So we're actually going to change, the key is going to be rolled at 6 p.m. today for the first time in the world. I think that around 6 p.m. today, all of us will be in buses or already at the party. My secret plan was actually to, hopefully we were going to roll the key before 6 p.m. so we would suddenly turn off the lights in this room or something to see how many people were screaming. But on the other hand, it's not exactly 6 p.m. because propagation time of zones and other kind of thing. So it's sort of 6 p.m.-ish. So anyways, so this is basically you have another 4 hours. You have another 4 hours to go to all your resolvers and validate that your resolvers have already sucked in the new incoming key. Okay? Because the incoming key has already been published for quite some time, several months, or at least the last month. I don't actually remember. I'm looking at Johan. Johan, how long time is it? A month? More? 6 months? Lehman? More than a year. Okay. So for more than a year, the incoming key has been published. So if you have a resolver that has done the right thing according to RFC 5011, it should already have the new key installed. If not, validation will not really work after 6 p.m. So I have a web page. You see the link there. We also, NetNode, yesterday evening, posted in social media also a text with that link, which tells you how you can validate and check whether the new incoming key has been sucked up by your validating resolver. I actually myself, being a good person, I checked my Unbound server at home. And of course, what I discovered was that I was using a little bit too old Debian. And in the Debian distribution for information, the version of Unbound is so old, so this cannot be used. Okay? And the instructions from Unbound is then you download and upgrade and do whatever, kill a duck or a chicken or something, whatever. Anyways, but it is possible to, you cannot really ask this query to sort of old versions of Unbound, but then by doing some, like kicking it in the back, I managed to get my resolvers to do the right thing. So check this, please. 3 hours and 58 minutes. So today, we're doing this for the first time in history. So let's hope that all of us that run DNS resolvers actually can have a fun time tonight and that you do not have to be on the phone. Okay. Any questions on this? And we are several people in the room here, including Lehman and Johan, of course, that do this much more operational than me. even though I do operation maybe more than them in certain corners. There are many other people that know DNS in the room from all of you here. Thank you very much for coming. So talk to each other and let's ensure that this actually works smoothly. Sweden is the country in the world where we have most validation in the world. Over 90% of the DNS queries are validated, so if something is happening, it will be here in Sweden. Let's take this first. Comments on this one? Yeah, that was a surprise. Sorry for not really synchronizing with the microphone carriers.
Okay, so I have a comment that I discovered last year. If you have an image of a resolver that you did a year and a half ago, and you then spin it up in a month, the new key will not be there. You cannot suck down the new key based on 2-year-old key. That information will be gone. So if this is how you deploy things, you need to respin that image and update the key. Because in a month, if I understand correctly, the new key will be the only key.
No, after 6 p.m. today, it will be the only key.
No, but it will not be... Oh, okay.
Oh, yeah, sorry. Yes, you're absolutely correct. The old key will still be there, but after 6 p.m., the old key will not be used to sign stuff.
Correct.
That is correct.
But I think you can, for 30 more days, you can still suck down the new key because it's still, like the old key is still valid, if I understand. Okay, anyhow, if in December you spin up an image that only has the old key, it will not work. So I think this is an important operational consideration that for people. Then it's also, I discovered personally, since I configured DNSSEC back when we started doing this in 2007 or whatever, I had new bind, but old config that did not update the key. So I didn't have to update my bind, but I have to fix my configuration, which is another point that you can run a very recent version of the code, but if you haven't updated your configuration, then you might still be in trouble.
That's absolutely correct. And to express what you just said in a different way, just to see whether I understand you, all your configurations and all your operating, running resolvers must have done RFC 5011 handshake between a year ago or more and now. Okay. So let's have fun tonight. The rest of the people can download SSH clients and whatever on your cell phones because you might need it. Göran Marby, CEO of ICANN, was commenting on me and Lehman and the Internet Stiftelsen today and said, yes, I'm going to make the order, sign the document, and then I will write about it in social media, how good everything is. And my comment was, of course, if you can. Next thing, NTS. This is basically what a clock is doing. A clock is doing two things. You have something that ticks, and you have something that counts the number of ticks. Not so difficult. The problem, though, are of course, to keep track of the phase of the ticking is actually happening according to what is agreed to, both the distance in time between the ticks and when the tick is happening. Both of them should be correct. And if you talk about the number of ticks, the difficulty is, of course, when you turn on the clock. At what number should you start count with, so you're not off by 1 error or something? So what you want to have is you want to have both good accuracy and good precision. And this is something like Ellen told this morning that we are very happy that we actually, at NetNode, the NTP and PTP service that we're running, we're actually better in both accuracy and precision than what we expected. Thank you very much, Ragge, Nick, and everyone else that works with the NTP project. Really well done. So, both of them. And I showed pictures like this. This is an old picture. We should produce new pictures that explains a little bit more what the node actually looks like. But basically, it consists of multiple different things. But as we all know, NTP, well, not all of us know. If everyone knew this, I would not have to tell everyone. But NTP is UDP-based protocol, and we know that you can very easily send UDP packets with whatever kind of content or whatever kind of sender address that you want. So it's very easy to lie. And that means that people might lie regarding NTP. So what about signed NTP? This is something that exists in the NTP standard, but the people that wrote the signed NTP standard, they were basically not crypto people. They were probably crypto people like me, but they were not crypto people. So the handshake of what key to use for the actual transaction was basically not useful. So the only signed NTP version of the protocol that is possible to use is something that uses symmetric keys. You have the same secret in both ends. We at NetNode, we have implemented signed NTP in the FPGAs that we have, and anyone that wants to talk NTP with us and have signed NTP, contact us, and we do an out-of-band in an envelope or something, PGP, exchange of keys that we then use for the NTP. But of course, this doesn't really scale. We can handle a couple of tens of thousands of keys, but then it doesn't really work. So we need to have a version of NTP where we can negotiate what secret to use in the actual NTP transaction. And this is where the MTS proposal comes into place. In the IETF, people have been working on TS for quite some time. And unfortunately, there are two camps, or even more than two camps, that could not really agree on how to do things. So what we decided to do at NetNode on request by PTS, that it asks us to run time and frequency, we spent some energy on looking into the current NTS proposal, and we saw that, well, wait a second, by doing some slight tweaks, we can actually come up with a version of NTS that is implementable, that we believe works, and also that the various camps actually can agree to. We submitted that in the summer, and it seems to be the case that we have some movement here, that people actually agree on how to do this. Partly, of course, this is not our fault, or thanks to NetNode. It was also probably about the right time, because people got tired over not having a proper version of NTP. So maybe it was just that people got tired. They didn't have energy to continue to fight. So we have a new version of the NTS proposal, draft IETF NTP using NTS for NTP 13 is the current version. The interesting thing here is that what we did, which is also the NTS proposal itself from the beginning, not our invention, is that we have a separate NTS key establishment protocol, which is using standard TLS 1.3, and you negotiate a cookie that is then used in the actual NTP transaction. So that is the first step. And then we have more or less a normal NTP protocol, but we use some extension fields to pass the cookie between the client and the server. The next important thing is that it is completely stateless from the server side, because we don't want the NTP server to keep state of the clients. So all the state of the communication between the client and the server on the NTP level is managed by is in the client side. So one can say that it is a Kerberos-like three-party negotiation using TLS and NTP, where the state is kept in the client. It makes sense? Okay, good. Whew, at least some people nodded. Maybe it's because you just want to be nice to me. Anyways, beat me up afterwards. So anyways, so this means that for the NTP service, which is where all the load is, we can basically use ordinary NTP with symmetric key encryption. What we already do, what we at NetNode has implemented, what we know works. So all the overhead with the asymmetric key exchange is something that is done on the server side. In the separate new protocol, we'll do the handshake. Much better than the old NTP thing. What else is new? Well, another thing that we did at NetNode is that because no one else has really large-scale experience of running NTP servers in Anycast deployments, we also ensure that the protocol can handle unicast, key exchange, and Anycast NTP servers. So this must also, not only a three-party handshake, and this is one of the reasons why it's important that the state is kept in the client, because you might send two different NTP queries to the same IP address, but you end up on two different NTP servers. So you have this kind of state machines. The KE server, you have the NTP servers, you have the client that negotiate. The parameters receive the initial cookie, and then you talk with any of the NTP servers in the Anycast pool. High-level interaction. So this text is not so much, it's a wall of text, not fun to talk about. I already told about all this, but I wanted this to be sort of in the documentation that you can download. This is what I think the key thing extracted directly from the internet draft for those who are interested. And the same thing for the NTP protocol, that the NTP server, as I said, is using the cookie to recover the key material in the initial response. And then the response includes a fresh encrypted cookie that the client then uses in the next step. So, as I said, very, very important that all the state is in the client, and a constant refreshing of cookies to handle replay attacks, the car key problem. So what is the status? Well, we hope from NetNode's side that people now agree on this. We heard from a couple of vendors that we are in contact with that they are even interested in implementing this, even if the IETF stalls and that individuals in the IETF don't want to move this forward. We intend to finish this internet draft and to implement NTS, both the server portions, the KE server, and also the NTP protocol, both as a standalone thing, and then also, of course, work on the FPGA. And this is part of the time and frequency project, and already in the original request from PTS that we should ensure that the protocol evolves. We have not had time and resources within the project to deal with this yet, but 2019 is when we will deal with this. So all of those of you who are interested in the evolution of NTP and not only using our services, make sure that we know who you are. We know who some of you are already, but if you're interested and have not heard from us, contact us and we'll make sure that you end up being involved. Thank you very much. Any questions on that?
So we have time for some questions for Patrik on the key rollover or NTS. Anything?
Just speak.
Rick, I just got a message from a guy called Ulf Kristersson. He had another issue he needs to be unstuck. Can you take care of that later?
Excuse me?
I just got a message from a guy called Ulf Kristersson. He had another issue that needs to be unstuck. Can you take care of that later?
Okay. Well, please join me in thanking Pat for...
A comment on that. I think just like Jan said, to be a little bit blunt on what we said in the project that we are working on, we have this coordination that we don't see in the government, but we have a lot of organizations at the bottom that are doing a lot of good things, like everyone in this room. So we have a very, very, very efficient bottom-up process. And the question is not what this bottom-up process can do thanks to the coordination up there, but what we can do even though we have a non-coordination up there. Right, John? Yes. Okay, thank you very much.
Thank you, Pat.